It is important to give children plenty of time to think and to exchange ideas with other children. The teacher actually waited 10 minutes before asking for volunteers to come to the board. The two children who went to the board proceeded essentially by addition to see how many groups of 20 they could make until they reached the total of 275.
Okay, Stephen, would you show us how you got your answer? Okay, speak loudly so that we can hear you.
Yeah. 20. That's, okay, 20 plus 20 is 40. 20 plus 20 is 40. 20 plus 20 is 40. Then 20 plus 20 is 40. 20 plus 20 is 40. 20 plus 20 is 40. Okay. 40 plus 40 is 80. Plus 40. 100. And that's 120.
Do you agree with him so far?
I agree. Yeah. Then that's 80 plus 40, 120, and 120 plus 120 is 240. I agree. And then plus 20 is 260. And you can't add another 20 because that would be 280. You're trying to get 275. And so, these are how many M&Ms?
Okay, so those 20s they stand for M&Ms?
1, 2, 3, 4, 5, 6, 7, 10, 11, 12, and 13. And I got 13. Remainder 15. I agree.
Okay, Jason?
Well, first I did 275 divided by 20 because there's 20 people in the class. And then I knew 10 times 20 equals 200.
Do you agree with that?
Yeah. Plus another 2 plus another 2 20s. Well, you know, plus 40 equals 240, and you've used 12 so far. You get 12 M&Ms so far. Then 240 plus 20 equals 260, and that you can't go any farther. So because it'd equal 280. So you have 10, 12, 13 M&Ms each. Remainder 15.
Stephen used only addition, but Jason used multiplication and addition. Let us go on to a similar problem.
All right, let's go to the next one. Now, we've talked about the small bag of M&Ms, but we haven't gotten to the medium bag. But I bought another medium bag, and I counted them. And I got 258, which is what we got yesterday, wasn't it? Is that the same? So it's just a small bag that had the different number. But now let's talk about that bag with 258 M&Ms in it. And Ms. Humphreys and I want in on this one. If we divide those up between the 22 of us, that's you plus the 2 of us, how many would we get then?
We will skip some time and see what two children did. The teacher actually allotted 10 minutes for the children to solve the problem and to exchange ideas.
All right. Katie, I would like for you to show the class how you got yours first.
22 times 10.
Speak loudly so that the whole class can hear you.
22 times 10 is 220. That's 10 M&Ms for the class. And Mrs. Johnson copies. And then plus.
Okay, tell the class why you circled that 10. I don't think they heard you.
Because that's 10 M&Ms. Class.
Do you agree so far with what she's done in her computation? Okay.
Okay. 220 plus 22, that's 1 M&M. An extra 1 M&M for another M&M for the class. It's 2 with 2. Then 1 plus 10 is 11. That's 11 M&Ms.
Are you in agreement with her so far?
Yeah.
Are you following what she's doing?
Yes.
Okay, y'all let her know if you're not.
We couldn't add 22 for the class to have another M&M because it would be over 258. Right? Okay, so we have to find our remainder. The remainder, okay, we have to say 242 plus what is 258? So then 2 plus 6 is 8, and then 4 plus 10 is 50. And 200 plus 0 is 200. So this is our remainder, just 16. Remainder of 16, and the class gets 11 M&Ms.
I agree. Ellen? Now, Ellen, you're going to have to try really hard to talk loud.
Well, 22 plus 22 is 44. And 44 plus 44 is 88. And from the 44 it is the 22, that equals 2. That means everybody gets 2 M&M.
Okay.
And so right there, everybody will get 4 M&Ms. 88 plus 44.
Speak louder, please.
88.
Ellen continued to add 44 several times until she reached 242. Katie, on the other hand, multiplied 22 by 10 as Jason did. This procedure came very close to the standard algorithm. Katie said in essence that 10 times 22 was 220, and one more 22 made 242, or 11 22s. However, all 4 children approached division very differently from the standard algorithm. First, they all worked up by addition and multiplication and never used subtraction. Katie even invented a way of getting the remainder by writing 242 plus what is 258. The second difference from the standard algorithm is that all the children kept 258 intact as a whole number instead of cutting it up into 25 and 8. It may seem more efficient to teach the algorithm, but when we ask traditionally instructed 4th graders why they work from left to right in division, but not in addition, subtraction, and multiplication, they always say they don't know why, but are following the rules given by the teacher. Such blind obedience is the opposite of critical thinking. Children will understand the rules much better if they are allowed to construct the knowledge they need to make sense of the algorithm.
Do I have enough in this package for everybody to have one?
Yes.
Okay.
Okay, there's 3 packages and 10 threes is 30, and you have 3 ones, and that's 33.
What do you think, David?
30 and I say so.
You think that's right? All right.